Hello everyone, welcome to TV Math Hub, your online home for clear, practical mathematics lessons. I am TV, and in every video, we focus on making mathematics simpler, one concept at a time. Let's get into today's lesson.
Let us now look at question number 3, which says we need to solve the equation, which is given as 4 sine squared of x plus 8 cot squared of x, which is equal to 5 cosec squared of x for the values of x which range from 0 less or equal to x less or equal to 360 degrees. So we shall look at the solution to this given equation. We shall look at how best we can first of all simplify this given equation, because we are given 4 sine squared, 8 cot squared, and 5 cosec squared. So to solve this equation, you must first of all create the relationship between sine squared, cot squared, and cosec squared. So how do we do that? So we have different ways of how we can do that. One, something that might be obvious is we can easily express sine squared in terms of cosec squared, because we understand that cosec squared of x is actually same as 1 upon sine squared of x, which means you can express sine squared in terms of cosec squared. So this is very possible. What about cot? Can we express cot in terms of cosec? It is also possible, because we understand that 1 plus cot squared of x is equal to cosec squared of x. So we realize that you can express cot squared in terms of cosec squared, you can express sine squared in terms of cosec squared. So if we are able to express each of these into the same function, then it will be easier for us to solve. So let us do that first. So we can say that 4 sine squared x plus 8 cot squared x is equal to 5 cosec squared of x. So we can write this as 4 times 1 upon cosec squared of x plus 8 into cosec squared x minus 1, and this is equal to 5 cosec squared of x. So we are putting each of these in terms of cosec squared of x. So looking at this, you realize cosec squared is common. So what we can do is we can let, for example, p to be cosec squared of x. If that is possible, we shall have 4 divided by p plus 8 into p minus 1, which is equal to 5p. So this will be 4 divided by p plus 8p minus 8, which is equal to 5p. So first of all, we can eliminate this p here by multiplying this p on each of these terms here. So when we multiply p throughout on each of these terms, so multiplying through by p, we shall 4 here, then plus this will be 8p squared minus 8p, then which is equal to 5p squared. So we can try to rearrange this by collecting like terms. So this will be 8p squared minus 5p squared, that will give us 3p squared, then minus 8p, and then plus 4, which is equal to 0. So that is basically what we shall have. So this is an equation which you can easily solve using either the factor method, or you can use a quadratic formula. So this will be able to give us p as a negative of negative 8 plus or minus the square root of a negative of 8 squared minus 4ac. A is 3, c is 4. So the whole of this is divided by 2a, that is 2 times 3. So this will be able to give us 8 plus or minus. When you simplify this, you'll be able to get what we call 16. So square root of 16 will be able to give us 4 divided by 6. So you will have your p as that. So it means p can be 8 plus 4 divided by 2, or you can have your p as 8 minus 4 divided by 2. So this will give us, this is divided by 6. This will give us 12 divided by 6, or else you have your p as 4 divided divided by 6. So it means that either P is actually 2 or P is actually 2 divided by 3. So these are the values of P, and having got the values of P as 2 and 2 over 3, then we shall now return back at the value of P. So remember that the value of P is representing cosec squared of x. So if P is representing cosec squared of x, we shall return it back, and this will give us, so let us consider for P equaling to 2, but P is representing cosec squared of x, so meaning cosec squared of x will be equal to 2. So this implies that cosec of x is same as the plus or minus square root of 2, and this will imply that 1 upon sine of x is same as plus or minus the square root of 2. So it means your sine of x will be plus or minus 1 upon the square root of 2. One, that the mistake that the majority usually do is when you take the square root here, don't only consider positive sign. Recall that square root of a number is a plus or a minus, and for that given case it implies, so when you only consider a positive sign, then you will be eliminating some angles. So you have to be careful, especially when you are dealing with trigonometric functions. So we are having sine of x equaling to that, and we need to get the corresponding angles in the range of 0 to 360 degrees inclusive. Now let us first consider, we shall first consider our sine of x, which is equal to 1 upon root of 2. This will give us x as sine inverse of 1 upon root of 2, and sine inverse of this is 45 degrees. So your x will be 45 degrees, but you will also need to get the values corresponding to x for where sine is positive. So you go to your quadrants and look for where sine is positive. Sine is positive in the first quadrant and this quadrant here. That is the first and the second quadrants. So here you will allocate your 45, you will allocate your 45 degrees. So it implies your values for x will be, the first one will be 45 degrees, this one here, and the next one will be this angle here, 180 minus 45 degrees, and that will give us a 135 degrees. So that is what we shall get for the values of x that lie in the range of 0 to 360 degrees. So having got that, remember we still have sine of x equaling to the minus. So let us also consider sine of x, which is equal to negative 1 upon root 2. So what we do here, we first of all consider sine of x equaling to 1 upon root of 2, and the angle we get here is what we call the principal angle. So clearly we have already seen that when you do that, you get your x as 45 degrees. So this will act as our principal angle, and it will help us to get the required angles. So what we shall do is, we need where sine is a negative. Sine is negative in the third quadrant and the fourth quadrant, and for that case we shall have to allocate our 45 degrees in those quadrants. So we shall take the angles from here up to this given point. This will be our first angle, and that angle will be same as 180 plus 45 degrees, and that will give us 225 degrees, 225 degrees. And the last one will be from here up to this given point, and that value will also be same as 360 minus 45 degrees, and that will be 315 degrees. So that is the value of x that we shall get. So in total we shall be able to get the angles as 45 degrees, 135 degrees, 225 degrees, then 315 degrees. So that is for the case when you consider, your p as 2, but we also have p as 2 out of 3. So we also need to look at that. So the one for p equaling to 2 has given us these angles. So we also need to look at the next, which is for p equaling to 2 divided by 3. So this implies that cosec squared of x is actually equal to 2 out of 3 because p is representing cosec squared. So for this case, it means that your cosec of x is same as taking the square root of this 2 out of 3, which you can represent as root 2 upon root of 3, but don't forget to include a positive and a minus. So for that case, it means we shall have 1 upon a sine of x, which is same as plus or minus square root of 2 upon square root of 3. So when you take the reciprocal, it means sine of x is actually same as plus or minus square root of 3 out of square root of 2. But you realize the value that you will get here when you take square root of 3 divided by square root of 2, you will get a value which is approximately equal to 1.22474, like that. So this value is greater than 1, and you know that the maximum and minimum values for sine is 1 and -1 respectively. So this is the maximum value, this is the minimum value. So any value that is less than this and greater than this will be undefined, sine will be undefined. So for this case, x here will be undefined. And if that is the case, then we shall now have our angles. So for 0 degrees less or equal to x less or equal to 360 degrees, the angles that will be satisfying this range will be the angles that we obtained here. That is 45 degrees, 135, 225, then 315 degrees. So that means that our values for x will be 45 degrees, 135 degrees, 225 degrees, and 315 degrees. So this will be the values of x that will satisfy at the given range, that is from 0 to 360 degrees. So that is one way of how you can solve this given equation, and we have seen that one here is by expressing each of these in terms of cosec. But we have another alternative that we can also follow, that is when we express now everything in terms of sine, because given this equation here, we can express it also in terms of sine. So we can look at that alternative case, and you choose the one that will be easier for you. So the alternative case can be, we are given 4 sine squared of x plus 8 cot squared of x, which is equal to 5 cosec squared of x. So we can express, because cosec squared can be placed in terms of sine, then cot we can also express it in terms of sine. So we can say this is same as 4 sine squared of x plus this one here can be written as cos squared of x divided by sine squared of x, which is equal to 5 cosec squared of x. So this cosec squared, let us write it in terms of 1 upon sine squared of x. So we shall be able to have this as 4 sine squared of x plus 8 cos squared of x is same as 1 minus sine squared of x, then divide this by sine squared of x, which is equal to 5 times 1 upon sine squared of x. So looking at this, you realize that each of these are in terms of what? In terms of sine squared of x. So from there you will do the same thing. You will let your p to be sine squared of x. So you will have 4p plus 8 into 1 minus p divided by p, which is equal to 5 divided by p. So you will multiply through by p, and you will have 4p squared plus 8 into 1 minus p, which is equal to 5. So you will try to simplify this, have this as 4p squared plus 8 minus 8p is equal to 5. So what will this give us will be 4p squared minus 8p. This 8 minus 5 will give us 3, will be equal to 0. So looking at this, you can easily solve this given equation. This is a quadratic equation which can easily be solved, and when you solve this, you'll be able to get the values of p. So the values of p will be obtained, and this will be 1 divided by 2, and another one will be 3 divided by 2. So you realize your p is sine squared, so you will have sine squared of x, which is 1 over 2, or you will have sine squared of x, which is 3 by 2. But of course, this will be undefined here. Sine will be undefined because 3 over 2 will be a big value when you take the square root. So here you will have your sine of x, which is plus or minus 1 upon the square root of 2, or else you will have sine of x, which is equal to plus or minus the square root of 3 over the square root of 2. So you recall what we got when we got this given expression. So this will be, this one here will not give you any angles. Here x will be undefined because root 3 divided by root 2 is greater than 1. But for this case, you'll be able to get the values for x. So from here, then you will come to the steps that we did from this given step here, especially when we reached at this given point. We were able to proceed very well together. So I hope you still recall what we did here. So these are the two different ways of how you can solve this given equation.